welcome back to your favorite intermediate algebra course. We're going to take a look at distance and midpoint formulas. We're going to use those today. So here's your distance formula, and this is just telling you a distance between any 2 points, just like this first example. Let's go ahead and make this a little visual here. 4, -5. So over 4 down 5. There's our 4, -5. We got -2, 7. Okay. So what is this distance? What is this distance? And this is derived from the Pythagorean theorem, by the way. So the distance d follows that formula, square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So you just need to take your 2 points, label them x1 and y1. Let's see the other one, -2, 7. x1, y1, label the other one x2, y2, and then just plug it into your distance formula that's been derived from that Pythagorean theorem. Okay. So here we go. You know, distance. What is the length of that line segment there? -2 minus our x1, which is 4. We got y2, 7 minus that y1, which is -5. So we got -6 squared, we got 12 squared. Extend this a little bit. We got 36 plus 144. So that ends up being what, 180? Okay. Which is, you know, if you punch that in, that's approximately 13.42. Okay. So that's about how long that line is, 13.42 units. Okay. Let's do another one here involving the distance formula. Let's say we're classifying a triangle. So you see this triangle ABC shown there to the right. Now, is this thing a scalene triangle, an isosceles, or an equilateral triangle? Of course, scalene means none of the side lengths are the same, if you recall from geometry. Isosceles means that there's 2 of the side lengths are the same length, right? Same distance. And equilateral means equivalent. They're all the same, all 3 sides. Equilateral meaning that all 3 sides are the same length. Okay, so you just got to go one by one for each line segment. So let's go ahead and let's go the distance for line segment AB first. Okay, so for AB, I'm using 1, 3, and 5, 4. Okay, I'm finding the distance of that line segment AB. I'm going to name this x1, y1, x2, y2, and the distance for line segment AB. Go ahead, make sure you write this each time so this becomes part of your memory. 5 minus our x1 is 1 squared. Our y2 here is 4 minus our y1 is 3. So we got square root of 4 squared plus 1 squared. So we got 16 plus 1, 17. Okay, so that line segment AB length is square root of 17. Okay, let's do the next one. Let's go from B to C. So from B to C, our B is 5, 4. Our C is at 4, 1. Okay, let's go ahead and name that x1, y1, x2, y2. So from B to C, that distance from B to C, write your distance formula. And start filling in. X2 is 4 minus x1, 5. Y2 is 1 minus y1 is 4. -1 squared is 1, -3 squared is 9. Looks like this ends up being the square root of 10. So the BC length, square root of 10. Okay, let's finally do from A to C. Okay, from A to C. So A, let me go back up to this here. A is 1, 3. C is 4, 1. Okay, so we're going to go from there to there. Write your formula. Plug it in. Our y2, here's 1. Minus our y1 is 3. 3 squared, 9. Looks like we get 13. So line segment AC is 13. So now I'm comparing all three of those. I say, well, the first one from A to B was the square root of 17 in green there, right? Square root of 17. Second one, square root of 10. Third one, square root of 13. Looks like none of them are the same, right? So I know it's definitely got to be a scalene triangle because none of the side lengths are the same, right? If two of those were the same, I'd say isosceles. If three of them were the same, I'd say equilateral. Okay, you got to find the distance for each of those points. Okay, now the midpoint formula. So this is just telling you if you got 2 points, give me the point that is exactly in the middle of those. Okay, so for instance, let's take this 1, -4. Let's draw this. Now, since this is kind of at a diagonal, it's hard to tell here. You know, you're going from this 1, -4, you got this -3, 5. What's the midpoint? What's the midpoint there of those two points? Of course, is our question. And you're like, well, I don't know. It's about right there, right, or so. Whoops, on the line. About right there, okay? But we're not exactly sure because this is not perfectly vertical and it's not perfectly horizontal. So what they do is this midpoint formula, you notice the x1 plus x2 all over 2 portion right there. Okay? They're just taking and they're finding the average, the mean of your x values, okay? So you know how your x values go from 1 to -3. What's the average between those? Like, well, the average between those is -1, right? And that's what you end up doing. So you're saying, well, from here, that x value to that x value, right in the middle would be that x, you know, that -1. And then the y's are just taking the average, you know, that y1 plus y2 is saying from here to here, what's your average right in between them? You're like, oh, it's right there, right? Okay, so that's what the formula is doing. The midpoint formula, it says take the average of your x's, comma, take the average of your y's, and you'll have your midpoint, okay? Make sure you label it x1, y1, x2, y2, or vice versa, okay? So the midpoint so x1 is 1, -4 is your x2, got -4 for our y1, 5 for our y2. Scroll down a little bit here. So we got 1 minus 4, so -3 over 2, comma -4 plus 5 is 1 over 2. So we got -3 halves, comma 1 half. Okay, that's our 1 -4 and -3, 5. Oh, you know what I just realized? Whoops daisy. That is my x2. Sorry about that. My x2 is a -3. Hee hee. So 1 plus a -3, that's a -2. It's a -2 in my numerator. Of course, my denominator's 2 already, so I got -1 and a half. There's the midpoint. That is the midpoint for those 2 points. Okay, so you can see it on the graph. It looks like we drew it okay. That point right there is at -1, 1/2 exactly. That is the exact midpoint. Okay, killed that one, but anyways. All right, so what if we're going to apply this, finding a finding a perpendicular bisector? Okay, so let's make a picture of this thing here. We're finding a perpendicular bisector of the line segment joining -2, 3. Okay, so here's -2, 3 and 2, 5. Okay, so you got this there's that line segment, right? From negative 2, 3 to 2, 5. Now a perpendicular bisector, bisector meaning splitting that thing, right? So we're going to split it right in the middle. So we're going to have to find that midpoint, whatever it is. I don't know if it's right there at 0, 4 or not, but we'll figure it out. We'll find the midpoint, and then it's got to be a perpendicular bisector. So not only does it split at bisector, but it's got to be perpendicular. Okay, what is the equation of this line? So that right there is your perpendicular bisector. Okay, so number one, we got to figure out the midpoint of this first. Okay, and then secondly, from that midpoint, we got to use the slope of the original blue line and figure out the perpendicular slope. Okay, and then we'll go from there and we'll write the equation. So let's find our midpoint here. So we're going from negative 2, 3, and we got this 2, 5. We're finding the midpoint, right? Find that midpoint first so that we can write the equation of that red line. So this is step one. Make sure you label this x1, y1, x2, y2. Midpoint of those would be x1 plus x2 over 2, comma y1 plus y2 over 2. And again, write that every time so that becomes memory for you. Just finding the average of your x values followed by the average of your y values. Okay, so the midpoint here, we got 0 over 2, which is 0, and we got 3 plus 5, 8 over 2, which is 4. Okay, so this point is right on the money, 0, 4. Okay, that's nice to know that. Okay, so that's step one. Step one. Okay, step two, now we got to find, we're going to go ahead and find the slope of the original line segment. And then we're going to use that slope to determine the perpendicular slope. Okay, so if you remember, the slope was y2 minus y1 over x2 minus x1, right? Change in y over change in x. So find this slope. Extend this a little bit. Okay, so we got 5 minus 3 over 2 minus a negative 2. So we got 2 over 4 or a half. So our slope is a half. That's for that blue line, okay? Looking up here, that's for the blue line. Now we want the equation for the red line, which means we need the slope of that red line, don't we? And we know it's perpendicular, so we know the perpendicular slope would be the opposite reciprocal. So we flip that 1/2 over, 2 over 1. It was positive, and now it's got to be negative, right? Because remember, if you take two slopes that are perpendicular, their multiplication of the two would be -1. Okay, that's why we take the opposite reciprocal. Okay, so again, you just flip it over and change the sign. So it was positive, now it's negative. So we know the slope that we're going to use is -2. So for our last step here, now we know for the third step, to draw this red line, I know my slope is going to be -2 of this red line. And I also know I have that point 0, 4 because that midpoint is on my red line, okay? So if I have a point and a slope, I'm going to use the point slope formula. So y minus y1 equals mx minus x1. Use the point slope formula from here because I have a point and I have a slope. And you go ahead and you plug the stuff in, okay? You finish it off. Okay, that is the equation. That right there is the equation of that red line. So the perpendicular bisector. So to run through this real fast, we found the midpoint of the original line segment. So now we know that one point is on that red line. Second thing we did is we found the slope of the old blue line. We flipped it over, changed the sign because we know it's perpendicular. That gave us the slope of the red line. Okay? That gave us the slope of the red line. And now that we know a point and a slope, we use the point slope formula to write the equation, and we're all done. See you guys in class. Bring your questions.